Following test is problem 4, and it comes from the book, page 729. It's example 4. I will do all the calculus, but I plan to leave out some of the algebraic computation. We have the following problem. It says that the profit for producing a certain item, x is units, profit is in dollars, given by the equation 4x cubed minus 210x squared plus 3,600x minus 200. It also says where the number of units produced is less than or less than or equal to 30. Since you can't produce less than 0 units, so that means x is in this interval between 0 and 30. Here there's no production at all. Obviously you're not going to make any profit. In fact, you're going to have expense. If you put in 0 for x, you get negative 200. And if you put in 30 for x, you get possible profit. And the question is to find the absolute maximum and what is the profit produced for this. In other words, we want to find what value of x, how many items should we produce that we get the maximum possible profit. It's a typical business problem. You want to maximize the profits, you have to know how many produce. Based upon what your costs are, the time it costs to run the machinery, how many you sell, supply and demand, there's many factors involved. It does not necessarily mean you should make the most possible, nor even a relative min or max. You have to look at it very carefully and analyze it. So we're going to do the following. We're going to try to find critical points. This function is defined everywhere. Derivative is defined everywhere because it's a polynomial. So what we worry about is what are the critical points when it's 0. So we want to look at p prime of x is 0, and p prime of x is going to be 12x squared minus 420x plus 3600, and we set that equal to 0. Now I can factor out at 12. This is 12 times x squared minus 35x plus 300. That equals 0. If you want, I can divide by 12 or just keep on factoring. This is 12 times x minus 15 times x minus 20. By the 0 principle, x equals 15 or x equals 20. Because this is a polynomial and nothing fancy, chances are one of these is relative max or relative min. But we want to find the absolute max. So remember we said before in drawing graphs, sometimes the relative max is the absolute max, sometimes the endpoint is the absolute max, even though this is not a relative, but this is. So we have to consider 4 values. We have to consider x equals the 2 endpoints. Here's our x chart, and here's our y chart. X is 0, and we consider x is 15, x is 20, and x is 30, the other endpoint. And we will substitute back into this equation and compute what is y. Here y is negative 200, a negative profit. If you put 15 in, you get the profit as $20,050. I'm not doing the arithmetic. I'm putting 15 in for x and computing this is what I get.
The original, yeah.
The original equation. I put 20 in, I get $19,800. So obviously this would then be a relative maximum to be a relative minimum, because polynomials will have relative max and minimum as we discussed earlier. So that would be the max, that would be the minimum. We can further verify if you want to go through all the work we did before, but it's not necessary for this problem. We put in 30, which is the endpoint, we get 26,800. That means the graph of this thing looks something like this. At 0, the profit is negative 200. At 15, it's 20,000. At 20, it's lower, it's like 19,800, so it goes like this. And at 30, it's up here like that. So this is x is 15. This is x is 20. This is x is 30. Since the endpoint is higher, we want the absolute maximum profit available. We had to produce 30 items to get it, and the profit would be that number. We did not do this arithmetic, but the idea is the same.